All right, now I want to talk about unit conversions, or what's called dimensional analysis. This is the math, guys. This is the math, and it's not hard. Um, you just have to understand how to put how to work these together. Okay. Um, so, what is it? What are we doing? Okay. Um, I think I have. Here we go. I got an empty page here. Okay, what we're doing. So, like I told you, the example was if you're traveling 60 miles an hour. Okay, so imagine you're driving 60 miles an hour and you drive for 2 hours. Well, in 1 hour I went 60 miles. In 2 hours I went 120 miles. That's what you're doing. Okay, this is basically the two things you need. You always need a given quantity, and you also need a conversion factor of some sort. Now, when I see you in class, I will hand out a page of conversion factors. They are English to metric conversions. Actually, if you go on D2L, you can download the actual form. I believe it's called conversion factors. It's under the forms. I think there's a link um, called handouts or forums. I can't remember the exact thing, but in there is a conversion factor table. Okay, like for example, it'll tell you that there's 2.54 centimeters in 1 inch. All right, that's a conversion. All right, that's a metric to English conversion. Okay, all right, or there's 12 inches in 1 foot. I don't think that one's there. I think everyone just kind of knows that. All right, that's an English to English conversion, but it's still a conversion. These are what conversion factors are. 12 equals a dozen. These are conversion factors. All right, they're equalities of some sort where they're taking one piece of information and converting it into a different form of information. Okay, so let's say we were, as a simple problem, how many, well, actually, before we do that, let me show you how you set this up. So you always write the given quantity first, okay, with its units, whatever its units is. Let's just call it unit A. Okay, this is how you set up the equation. And then you're going to multiply it by a conversion factor. And the conversion factor is a ratio. All right, so you have a number. So whatever unit you have here on top, this technically is on top of the equation, the same unit goes on the bottom of the equation. So whatever unit, so if you have inches here, then your inch quantity is going to go down here. All right, and then whatever quantity you want as your answer, that goes on top. So you're going to have some sort of number with the B unit and some sort of number with the A unit. It's really not even the numbers that are that important, it's the units. The reason we do this is so that this unit can cancel out with that unit. Treat units as if they're variables, like in algebra. Like if I have x, y divided by x, what does that equal? Well, that equals y, right? Because the x's cancel each other out and equal 1. So you're left with y. That's what we're doing here. And then you take your given quantity, whatever number it is, multiply it by whatever number this is, and then divide by whatever number you have here, and that is your answer. You have just did a conversion. And this is what unit analysis is. All right, and that's what you did when you're traveling 60 miles an hour, 60 miles per hour, all right, and you're going 120 miles. All right, so this is my conversion factor. So my given quantity is 120 miles. Why is that the given? Usually the given quantity only has one unit attached to it. It doesn't have the 2 units. This is what miles per hour mean, okay? So I'm going to multiply it by the conversion factor. Now miles has to go on bottom. Why does miles have to go on bottom? Because it needs to cancel out, okay? So that means hours has to go on top, all right? So the 60 is with the miles, so 60 goes down with the miles, and 1 hour goes up here. So the answer is 2 hours. Now, I believe I did this problem backwards. I think I asked you how many hours would you go in 120 miles, but whatever. It doesn't matter. It's the same thing. If you go 120 miles and you're going 60 miles an hour, how long is it going to take you? 2 hours. All right? Because I did 120 times 1 divided by 60 equals 2. This is what unit conversion is. This is the math in this class. Okay, if you can set up equations like this, the hardest part is figuring out what conversion factor you have to use. Okay, so let's do just a real quick practice problem just to make sure you understand the basics. Okay, now when I see you next time in class, we are going to do tons of problems. Okay, tons and tons of problems. You will be bored. All right, I'm going to make this easy. How many eggs are in, whoop, are in 5 dozen? Now, I know you can probably do this in your head, but what you're doing in your head is dimensional analysis. I'm going to show you what you are doing in your head mathematically. Okay? First of all, what's my given quantity? 5 dozen. That's my starting point. All right, I'm going to multiply it by a conversion factor. What has to go on bottom? Before we do anything else, what has to go on bottom? Eggs or dozen? Right, dozen. I'm assuming you said dozen, that's why I said right. Because whatever unit you have here, that's the same unit that goes on the bottom, and eggs is on top. So now I got to figure out what numbers. Well, I know there are 12 eggs to 1 dozen. So here's my equation, 5 times 12, all divided by 1. So the answer is 60 eggs. There you go. Pretty simple, right? I hope you're sitting there saying, that's easy, I can do that. Well, good, because that's all it is, guys. There's no tricks. So let's go back to what we were talking about. So they're kind of showing you what a conversion factor is. They're saying that 1 inch equals 2.54 centimeters. So they're saying you can write it either way, either 1 inch over 2.54 or 2.54 over 1 inch. How do you know which direction to use? Depends on your given quantity. If you're converting 10.5 inches into centimeters, well, this is the way I would do it, right? I'm sorry, 10.54 centimeters into an inch, because I want the centimeter to cancel out with the centimeter. If I'm converting, let's say, 11 inches into centimeters, I would now do 1 inch over 2.54 centimeters. So I'm now going to multiply. Okay, that's how you know which direction you have to use. Okay, so here they're just showing you a problem. You need to convert 12 inches to centimeters. That's my given quantity, 12 inches. What's my conversion factor? Well, 1 inch equals 2.54 centimeters. What has to go on bottom? The 1 inch, because I need the inches to cancel out. So it's 12 times 2.54 centimeters, and that's how many centimeters there are. All right, guys, we just did this. This is exactly what we just said. These are the conversion factors I told you to memorize. All right, this was way back in what, unit 4.1, 4.2. All right, this is basically, you know, a kilo. So like 1 kilometer is 1 times 10 to the is, you know, 1,000 meters. All right, these are the conversions. So, you know, you've probably been watching this video now, so I'm sure you have these memorized, right? Totally memorized. All right, remember there's 1,000 meters in 1 kilometer, you know, or there's 1 meter in 1,000 millimeters, right? These are conversion factors. This table I told you to memorize are metric conversion factors. All right, here's more. This is the smaller ones like the deciliters, okay, nanoliters. All right, so part of this chapter they talk about density and the density equation. All right, density equals mass over volume. All right, well, density, your final answer should always be, it's usually grams per centimeter cubed. All right, by the way, guys, what does centimeter cubed also mean? Do you remember from the very first slide? It also means milliliter, so grams over milliliter. That's usually what density is. Okay, some people express it in kilograms per meter cubed. That's another way of doing it, but it doesn't matter if you talk about kilograms per meter or grams per centimeter. It doesn't really matter. Okay, so this is just kind of showing you another problem. What if you're converting inches into meters? Okay, well, let's just say on your piece of paper, I know how many inches are in a centimeter, all right, but I don't know how many inches are in a meter. Well, I know I can convert inches into a centimeter. Then you can do another conversion and convert your centimeter into a meter. So 12 inches, okay, to get to a centimeter, I know 1 inch is equal to 2.54 centimeters. Inches cancel, and I'm left with centimeters. But now I need to get to a meter. Well, I know there are 100 centimeters in 1 meter. because a centimeter is smaller than a meter, so I need 100 of them to get to it. So that cancels each other out, and it gives you 0.3048. Okay, what I suggest you do is try to do problems, start doing problems. In your book, I'm sure there's problems. Otherwise, I'll see you in class, and we will do tons of these in class. But the sooner you get on top of this, the sooner you understand it, the better off you're going to be. Okay, so I will see you guys in class. That was the end of the
slides.
and like I said, try to get on top of this. I will post problem sheets for you guys. If they're not posted, then you will get them in class. All right. So get your questions, and I'll see you in next class. Bye.